Okay, kids, here we are for lesson 3.2.3. We're going to start with number 89, and here is the process. So in this problem, the textbook is already giving you all this information from something that you found way back in lesson 313, which of course we did not do. However, knowing all of these is not necessarily the significant thing, but what we do need to know is that this is the equation that relates the figures, okay? So if I'd said x equals 0, what does that look like? Well, figure 0 would be just 3 little cubes. 1, 2, 3, because that's how much it's worth if x is 0. And if x was 1, that is going to equal 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. If x is 2, figure 2, that's going to be 2 times 6 is 12 plus 3, that's 15. And it goes on. Figure 3 would be 18 plus 3, which is 21. And you can count those on your text to see what they are worth. So what they're asking you is this Penelope girl, whoever this is, I don't know if she's a nice kid or not a nice kid, but in any case, she wants to find out how many tiles will be in figure 50. So really, what we're doing is we're increasing by 1 each time, and every time we increase by 1, we multiply by 6 and add 3. So here's what we do. Y will equal 6 times the 50th figure plus 3, and that's all there is to it. So when you multiply that out, y equals 300 plus 3, which of course is 303. That's how many squares or blocks there are. That is the solution to number 89. Let's go on to so if you're done with 89, great. Please make sure you do problem 90, and I will pause here for a second, and teacher, if you would, please pause the video. Thanks. Okay, we're on to number 90. 3-90. I hope that's within your picture range. It should be right there. Lou wants to reverse the process. He has a big C's figure. Okay, he wants one of these figures right here with 45 tiles. So when we put 45 over here, somehow we need to take this equation, y equals 6x plus 3, and figure out where 45 goes. Does it go in here, or does it go in here? Well, 45 is the outcome, so we put 45 here, and we simply solve the equation and can figure out what x is going to be. Okay, so what I'll do is I'll subtract 3 from each side, just like we would any other algebraic equation. When I do that, this becomes my 0 pair. This becomes 42 equals 6x, and many of you can already see it's going to be 7, but let's divide and make sure. This is my giant 1. X equals 7. That's number 90. That's part A. Which variable? Which variable? A. The answer is the y variable. Part B. Write an equation you would use to solve Lou's problem. Then solve your equation, recording all of your steps. Which big C's figure is made up of 45 tiles? I put it right here. We didn't do the counting part before to figure it out. We didn't learn that step. But we can certainly say, to go on just to part C and say, hey, we solved by doing this. Okay, that's part C. Number 91. Please pause the video and we'll move on to 91. Okay. 91. Norm says he has a big C's pattern made up of 84 tiles. He wants to know which figure number the pattern is. Write and solve an equation as you did in problem 90. Does your solution make sense? Why or why not? I think it's pretty straightforward. He wants to know which figure number the pattern is. Okay, well, if we have 84 tiles and we had this was our pattern. Okay, it's that straightforward. We simply say 84 equals 6x plus 3. I'll subtract 3 from each side. 81 equals 6x. If I divide by 6, I divide by 6. Does that divide evenly? I don't think so. 6 goes into 81 once. 6 does not go into 21 evenly. So 6 times 3 is 18. 3. It's going to be 3/6, or 13 1/2. 13 1/2. Does that make sense? We have to determine if it makes sense or not. Well, it doesn't necessarily make sense because it's hard to have half figures. However, you know, if you wanted to have fractional figures up here, I guess we could put something in between 2 and 3 and make a fractional figure. I'm not really sure. What do you guys think? You want to take a stab at that? Well, look, folks, it grows continuously. Tiles can be cut into pieces. So yes, we could have figure 13 1/2. Okay? It can be created. All right, there's number 91. I wish all of you a good day. However, I am going to do number 92. If someone needs to see those done, it'll be on the back half of this page. You can pause now and then come back if you need to. Thanks. All right. Let's look at number 92A. We have, can you see it? 1/2 x minus 2 equals x minus 4. What is this? How can we make this? What do we do here? Well, I know this is an x term right here. That's an x term. This is an x term. I can somehow get those combined on one side. So if I go ahead and subtract 1/2 x, I'll get 1/2 x there. Might it be easier if we go ahead and multiply everything by 2 to get rid of that denominator? That might be easier. Let's just do that. I'm going to multiply everything by 2. 2 times 1/2 is 1x. 2 times negative 2 is negative 4. 2 times x equals 2x. And 2 times 4 equals 8. So this is what I should have if I multiply everything by 2. It gets rid of my fractions, makes it a little easier. All right. I'm going to go ahead and subtract 1x from each side first. Okay? When I do that, this is a 0 pair. I get negative 4 equals x minus 8. Next step, I would add 8 to get the x terms on one side and the whole number of terms on the other side, or constants on the other. I end up with x equals 4. That's your solution for 92A. Here's letter B. Letter B, letter B. 0.25x equals 0.5 plus 2. Well, I have all these decimals, although decimals aren't too hard to work with. I think I'll go ahead and just leave it as a decimal. So my first step, I think I'm going to get all the x's on one side. Let's see, that's a 0.5x. If I add 0.75, add 0.75, or 0.25, add 0.25, I was thinking ahead. Add 0.25x. That gives me 0 x's here. 8 equals 0.5 plus 0.25 is 0.75x plus 2. The term with the x is here. So I'm going to go ahead and subtract 2 to get the constants on the left side. 6 equals 0.75x. I can go ahead and divide both sides by 0.75. 0.6, let's see, 6 divided by 0.75. I think that ends up being 8. 8 equals x. Yeah, you can put it in your calculator, or you can do it this way. 0.75 goes into 6.0. Or look, it's a fraction. I can do this. Six divided by 0.75 over 1, or 6 multiplied by 1 over 0.75. I guess that doesn't help. Yeah, just do that division. You'll find out that it's 8, because you move the decimal place twice. That's where your decimal point would be. 75 goes into 0. That's actually 8. 8 times 75 will be, 8. Let's move on to letter C. Letter C. Let me get to the right page on my computer. Letter C. We have x plus 2 minus 0.5x equals 1 plus 0.5x plus 1. I think I'll go ahead and combine like terms first. Okay, if I combine like terms, I have x minus 0.5, so x minus 1/2 is going to be positive 0.5, and then we x plus 2 equals, these two added together will be 2 plus 0.5x. What do you guys notice? Well, I notice if I take away 0.5x on each side, this becomes a 0 pair, that becomes a 0 pair, I get 2 equals 2. That means all numbers are solutions. There you go for letter C. Letter D is going to look like this. I'm going to zoom in just a little bit to help. Maybe we'll see that a little better. Okay. Letter D. Sorry about the bobbing and weaving there. Letter D. We have 7x minus 0.15 equals 2x plus 0.6. Well, I think what I'd like to do is get rid of the decimals. There seems to be enough here on both sides. Let's go ahead and multiply everything by a power of 10 to get rid of the decimal points. Okay? The greatest power of 10 that I should multiply by is 100. If I multiply by 100, this largest decimal, the longest decimal, will be removed and made into a whole number. So let's go ahead and multiply everything by 100. That gives me 700x minus, multiplied by 100, that becomes 15, equals 200x plus, move it twice, that would be 60. We can go ahead and solve that by combining like terms, etc. Let's see. I think I'll start with subtracting 200x from each side. When I do that, here's what I get. I get 500x minus 15 equals 60. My next step, I'm going to move the constant to this right side. I'm going to go ahead and add 15. Add 15. That gives me a 0 pair here. 500x is what remains on the left side. And over here, I get 75. To find x, I divide by 500. Divide by 500. Okay, this is my giant 1 and becomes just a big old 1. And then I have x equals 75 divided by 500. Well, if I want to do long division, I can. I have a calculator somewhere. Maybe I'll just put those numbers in and we'll see what we come up with. So for letter D, I get 0.15. Okay, so x equals 0.15. That is letter D for number 92. Let's go on to number 93. 93. Again, pause the video. If you're working on this in class, try it first, and we'll go on. Okay? Let's try number 93. This is a really unique question for number 93. Can an equation be solved using a graph? Consider this as you answer the questions below. Solve the equation 5 equals 1/6 x plus 1. If you solve, could you draw a graph of that? Oh, it's not 1/6. I apologize. It's 1.6. 5 equals 1.6 x plus 1. Solve the equation. Sure, why not? Let's subtract 1 here. I get 4 equals 1.6x. So when I get 1.6x, I'm going to go ahead and get my calculator out if I can find it. There it is. Found it. Four divided by 1.6 equals 4 divided by 1.6 equals 2.5. So it's 2.5. Okay? Now, check the solution. So I'm going to go back into the original equation. I'll bring that right over here. The original equation is 5 equals 1.6 times x plus 1. What did we find x to be? 2.5. So I'm going to put it right here. And let's see what we can come up with. Let's see. 1.6 times 2.5 plus 1. Sure does. It equals 5. Okay, so yes, it works. Check my solution. Part B. Complete a table for y equals 1.6x plus 1. Then, on graph paper, graph a line. Okay, well, I'm going to use my calculator here because it'll help me multiply numbers a little quicker. All right, let's make a table. We can make a table horizontally or vertically. I like to make mine vertically. Can you do this? We call this a T-chart. Call it a T-chart. So we put our x here for an ordered pair. You know, we make an ordered pair. I'm going to put my y here. What is y? Y equals 1.6x plus 1. So what we're going to do is take our point x and put it in there. So let me see if I can find a straight edge. This might work. Since I don't have an actual straight edge ruler, oh, that's not very straight. Can't use that. I guess I'll use my handy dandy clipboard. Okay. I got some dampness on that paper. All right, so if I put a value in for x, let's put a value in for x. What's the easiest one to put in? If we start with x being 0, that makes this x 0. Right there. So if that's 0, we have y equals 1.6 times 0 plus 1. That's 0, so y equals 1. See, the easiest one is choosing x to be 0. Then let's go on with some others. It might be easiest to pick some numbers that would multiply nicely with 1.6. Like, let's say 4. Put 4 in here in this equation. Y equals 1.6 times 4 plus 1. 1.6 times 4. 1.6 times 4 is 6.4 plus 1 is 7.4. Okay? Do you know you only need 2 points to make a graph? But because all we have to do is find the point, 0, 1. So in my x direction, this is positive, I go 0, so an up 1. There's 1 point. My second point is I go over 4, 1, 2, 3, 4, and up 7.4. 2, 4, 6, 7.4 would be about right there. Just a little bit less than half. I could draw a line and there it would be. However, to check yourself, make sure you always put 3 points in there. Let's choose a negative value. What if I chose 1, let's put negative 4 in there. How about that? Negative 4 in this equation here, right there. Negative 4. So if I put negative 4 in there, negative 4, y equals 1.6 times negative 4 plus 1. Well, we know already that 1.6 times 4 is 6.4, so that'll be y equals negative 6.4 plus 1. Okay, 6.4 plus 1. And that will be negative 5.4. So I go, let's see, negative 4, 1, 2, 3, 4, and negative 5, 2, 4, 5.4, right there. Does that look like a straight line? It sure does. You can make as many points as you want, but 3 of them should suffice when you're simply, when you have an equation. Okay, so when you graph that, here, let's graph it. Let's finish it, make it look good. I'm gonna zoom out a little bit, right there, so that way you can see it nicely. There you go. Can you solve exactly with a graph? Probably not, but you can certainly get a good idea of where the result would be. Let's say I wanted to know what the value of 1 is when I put 1 in for x. Well, it looks like it's going to be about 2.5. How about the value of 5? There's 5. Let's see, we go 2, 4, 6, 8. It's going to be about 8 3/4 roughly. Okay? All right. Use the graph from part B to find x when y equals 5. Did you get the same result as in part A? Well, if I put y equals 5 in there, using that part, we can find x when y equals 5. Oh yeah, 5. 1, 2, 3, 4, 5. That's going to be about 2, 4, 6, 8. That's about 8.5. Is that what we came up with? Oh, when y equals 5? Or x equals 5? When y equals 5. Oh, when y equals 5. 1, 2, 3, 4, 5. Here's where y equals 5. 1, 2, about 2.5, folks. That's roughly 2.5. Is that the answer that we got for the first part? Part A? Yeah, we did. For part A, we got x equals 2.5. So if you draw with graph paper, you're going to be pretty darn close as long as you keep everything nice and straight. So that's number 93. Did we get the same result? We did. But sometimes you may be off just a little bit, so be really careful. Use a straight edge when you're trying to graph a problem. There are your problems for the lesson today. Didn't take as long as you probably thought. Okay, have a great day.